We have already looked at how to find the equation of the line when you're given the graph itself, the table of values, or when you're given the slope and the y-intercept. Today we're going to look at how to find the equation of the line where no visual is provided and you're just given the slope and a point. But before we do that, we do have to do a quick little refresher on how to multiply fractions. Really, when you have fractions, you multiply the tops, which are the numerators, multiply the denominators, which are at the bottom, and then reduce it. If you have a number that isn't in fraction form, you have to put it over 1 first, and then do those steps. So if we see 8 times 3/4, I'm going to put the 8 over 1, and then I multiply my tops, which are 8 times 3 to get 24, and then multiply the bottoms, 4 times 1 to get 4. And then I reduce. 24 is actually divisible by 4, so our answer is just 6. The next one, again, I put the negative 18 over 1, I multiply the tops. Negative 18 times 2 is negative 36. 1 times 9 on the bottom is 9. And this again reduces to a nice whole number of negative 4. If it reduces to a whole number, write it like this instead of over 1. It'll just make your life easier in your calculations. And finally, negative 2, I put it over 1. The tops, negative 2 times negative 2 is positive 4. And then 1 times 5 on the bottom is 5. And that's as far as we can go. Okay, let's actually get started here. We're going to find the equation of the line given the slope and the point. I have the steps on the right and we will follow them. I'm going to do one example where I do it fully algebraically, and then for the second example, I'm going to do it using a graph and the visual. And you will have the option to use either method depending on your preference. All right, so our line has a slope of 3 and it passes through the point 2, 1. We know that every equation of a line is in the form y equals mx plus b. Well, this slope of 3, that 3 represents m. So let's just start off by replacing m with our slope. Y equals 3x, but I don't know the y-intercept. So I have half of the puzzle. I just need to figure out the last piece. So that's step 1. Now, in order for us to figure out b, or the y-intercept, we have to use that coordinate. A coordinate is always made up of an x and a y. So in this case, x is 2 and y is 1. And our equation has an x and a y in it. So we're going to plug in our points for x and y. So instead of y, I'm going to put the 1. And then instead of x, I'm going to put the 2. So step 2, done. Now you will notice the only variable we have is b, and I can easily isolate for it. So I'm going to do my quick multiplication. 3 times 2 is 6. And now this is just a one-step equation where I bring the 6 over, changing the sign. 1 minus 6 is negative 5. And now I have my y-intercept, so let's put it back into our equation for b. And your general equation, that point is nowhere to be found anymore because your general equation should always have a y and an x in it. So y equals 3x subtract 5. And honestly, when you're isolating for b, it will always be the same steps. You'll do your multiplication, then you'll bring that number to the other side with the opposite sign. So this is an algebraic way. We can also do this process using a visual. So I will show that here. This line has a slope of 1/2 and it passes through the point negative 4, negative 10. So I have a point, so why don't I plot it? Negative 4, negative 10 is all the way down here. Now let's use that slope. My slope is 1/2, which means I rise 1 and I run 2. Now typically we start at our y-intercept to apply this rise and run, but here we're given this random coordinate. So let's start from that coordinate, apply our rise and run. We already know the slope. Our goal is let's just figure out the y-intercept and then we're good to go. So once I hit the y-axis, I'm happy and I can put my equation together. So rise 1, run 2. Okay, I'm not there yet. Rise 1, run 2. In that second step, I got it. I got to the y-axis. That is the y-intercept so b is -8. I will just connect my dots because why not? And now y equals my slope because it was given to me, and then the y-intercept is -8. So there we are. So if you like the visual way, you're more than welcome to do it. I'm an algebraic person, so I personally would do the other way, but the choice is yours. All right, let's try some more. So I'll do both methods again here. So in this scenario C, we have a slope of 3/2, and our point is 4, -1. So step 1, put your slope into your equation. Step 2, I used that, so I'm done with that, but I still have my coordinate, which is an x and a y, so I'm going to replace y with -1 and x with 4. Now I do notice that my slope is a fraction and I'm going to have to multiply the fraction, so I am going to put the 4/1 so I don't do something silly. Okay, now we're going to simplify the multiplication. 3 times 4 is 12, 2 times 1 is 2. And this step is really important. If you can reduce the fraction, and you always will be, reduce it. 12/2 is 6. Don't write 6/1. If we can get rid of the fraction, get rid of it. Now let's bring that 6 over. -1 subtract 6 because we changed the sign, and we get -7 for b. And now we can put it all together. Y equals 3/2x subtract 7. So in this scenario, we did have a little bit of that fraction multiplication, but otherwise the steps are the exact same. If you wanted to do this using the graph and the visual, I will do that as well. Our point is 4, -1. Here it is. And our slope is 3/2, which means I want to rise 3, run 2. Now, if I do that and I go up 3 and then to the right 2, I'm getting further away from my y-axis, so that's not doing me any good. So I'm going to change both directions. Instead of going up 3, I'm going to go down 3. And instead of going right, I'm going to go left 2. So 1, 2, 3 down, 1, 2 to the left. That way I continue the line direction correctly. 1, 2, 3 down, 1, 2 to the left. So sometimes you do have to do your rise and run in the opposite direction so that you actually get to your end goal. And here is that y-intercept of -7. So then we can take our slope, we can take our y-intercept, and you get the exact same equation. And again, I will connect my dots. So either method would be perfectly fine. So I want you to pause the video here. I want you to try D on your own using whatever method you prefer. And then come back to check your work. All right, so for the algebraic method, here's my slope. My point is x comma y, so 6 for y, -5 for x, which I'm going to put over 1. And now we clean up. -2 times -5 is +10, so be careful there. And then 5 times 1 is 5. The 10/5 does reduce to a nice whole number of 2. And then we can bring the 2 over. 6 subtract 2 is 4. So it does get very repetitive, so if you choose this method and you practice it, it does get quite quick. Now I do recommend you practice both methods before you pick one, but there's the algebraic way. Now let me show the graphing way. So -5, 6 is right here. Now just one thing about the graphing way, if you plot your point incorrectly, if you do your slope incorrectly, this is all going to be off. So yes, it can be very quick to do, but it could be also very easy to mess up. So from my coordinate, I'm going to apply my slope of -2/5, which means down 2 and then to the right 5, because the run is positive. So I'm going to go 1, 2 down, 1, 2, 3, 4, 5. And I actually hit the y-axis right away. So there's my y-intercept of 4, which is exactly what we got algebraically as well. All right, the last two examples we have here are slightly different in that their slopes are a little more special. We have a slope of 0 scenario and an undefined slope. Now with the slope of 0, you can really treat this the same way. So I see my slope is 0, so I can go y equals 0x plus b. Okay. My point is 8, 5, so instead of y, I'll put 5, and instead of x, I'll put 8. Now 0 times anything is 0. So 0 times 8 is 0, that disappears, and there's nothing to move over. So 5 equals b, which means you can technically write your equation like this, but 0 times x is kind of silly because it does disappear. This is the final equation. Now this was kind of a long way to do it. I personally wouldn't do it this way. When you see a slope of 0, if you remember your slope properties, you can go straight to remembering that this is a horizontal line. And if you remember a horizontal line always has the equation y equals a number. And it's going to be the y coordinate of your point, which is right here. But I could also look at my visual. 8, 5 is right here. If my slope is 0, that means 0 over 1. I'm not rising at all. I'm just running. So there's the horizontal line going through 5. So you can still follow the same steps, but if you remember the horizontal connection, you can get to your equation a lot quicker. But either way is fine. Now for the final one, we have an undefined slope. Well, undefined, I can't use y equals mx plus b because I can't write y equals undefined x. Makes no sense. So here we really have to remember undefined means a vertical line. But even if you don't, undefined means you're dividing by 0, which we're not allowed. So the slope would be something like 1 over 0. So even if we don't remember it's a vertical line, I can plot my point at -1, 7, and then I'm going to rise 1, but I'm not going to run at all. So I end up with this vertical line. And what does the vertical line pass through? It passes through -1. So my equation, x equals -1, because every single coordinate on this vertical line has an x value of -1. So this one, you can't follow that y equals mx plus b form. You do have to remember that undefined slope connects to a vertical line. But besides this exception, every other scenario, plug your slope into your equation for m, plug your point in for x and y to isolate for b, and then put it all together. Or graphically, plot your point, apply your slope, and visually see that y-intercept.